I'm going to do the first column of problems for this Unit 10 Spiral Topics worksheet. All the questions on here should be at least vaguely familiar to you, and they're all spiral questions that pop up on the Unit 10 summative. On number 1, we want to factor completely, so we want to find the largest number that both 4 and 8 are divisible by. Notice that the first number is negative, so we want to take out a negative version of the greatest common factor. So 4 and 8 are both divisible by 4. And since, again, the first term is negative, I want to do negative 4. Looking at the variables, both terms have at least an x to the 4th, so that'll be part of my GCF. And both terms have at least a y to the 4th, so that'll be part of my GCF. So I want to divide all of my terms by the greatest common factor. The greatest common factor needs to be written out in the front, and then to get the leftovers in the parentheses, we need to divide. So negative 4 divided by negative 4 cancels out to 1. X to the 5th divided by x to the 4th. When you're dividing like bases, subtract the exponents. So 5 minus 4 would be x to the invisible 1, but I don't usually write that invisible 1 in the final answer. Y to the 4th divided by y to the 4th. 4 minus 4 is 0. Anything to the 0 power is 1. So y to the 4th divided by itself cancels out to the number 1. In the back, 8 divided by negative 4 is negative 2. X to the 4th divided by itself cancels out to 1. And then y to the 6th divided by y to the 4th. You're dividing like bases, so subtract the exponents. 6 minus 4 is 2. Now remember, if you multiply this back out, you should get what you started with, because factoring and multiplication are inverse operations of each other. They undo each other. For number 3, and I would recommend pausing the video and trying number 2 right away. Then on number 3, we're supposed to describe the transformations that have happened. So I would just go left to right. The 1/2 is a number in the front, so it's the a value. Since it's in between 0 and 1, that's going to be a vertical compression. If it had been a number greater than 1, that would be the vertical stretch. But it's a compression because it's in between 0 and 1. Then the +3 is inside the parentheses, so it's a horizontal translation. Horizontal translations are always the opposite of what we think they should be. So I see a plus, which means I actually go left. So horizontal translation, left 3. And then in the back, a -8. It's in the back, it's a vertical translation. They are as they should be. So up is positive, down is negative. Vertical translation down 8. And then I would pause the video and try number 4. On 5, it's usually helpful for us to put in negative infinity on the bottom and the left, positive infinity on the right and the top. And then while we're at it, let's put our axis of symmetry in here, which has an x value of 0. So now everything's kind of labeled, which makes it easier to do the rest of the problem. Our vertex would be way up here at the top, so the highest point on the graph in this case. So let's see, what is that? That looks like 0, 4. And then axis of symmetry is always x equals whatever the x coordinate of the vertex is. So x equals 0. And you need that x equals, otherwise it's wrong. Domain is always negative infinity to positive infinity if it's just a normal standalone parabola, not in the context of a word problem, which is what we have. And remember, domain is your x values. Range is my y values, little to big, bottom to top. So negative infinity all the way up to our highest y value up there is at 4. And I want a square bracket after the 4 because I want to include that in my answer. For interval of increase, I want to look at the parabola from left to right. It's going up on the left side, right? It's going up over, whoopsies. It's going up over here. So from when x is negative infinity to when x is 0, that whole left side of the graph, we're increasing. And then keep going left to right. when x is 0 all the way until when x is infinity, we are decreasing, going down. So on this side, we're going down. I would pause the video and try number 6. For 7, you're multiplying. So the 4 and the -2 just get multiplied like normal. And then, careful, the x's are not in order. So make sure you're only multiplying like bases. And also remember there's an invisible 1 on this x right here. So 4 plus 1 makes that x to the 5th. And then for the y's, you have a y to the 7th times a y squared. 7 plus 2 is 9. I would pause the video and try number 8. With number 9, when you're dividing like bases, you want to subtract the exponents. And again, remember there's an invisible 1 on that x. For the coefficients, the 5 and the 10, the numbers in the front, divide them or reduce them. So in this case, 5 and 10 are both divisible by 5. So that's going to reduce down to a half. Because up top, 5 divided by 5 is 1. In the numerator, in the denominator in the bottom, 10 divided by 5 is 2. So 5 over 10 reduces to 1 over 2. Again, be careful. The x's and y's don't line up. So make sure you're matching up the variables. So x to the 9th divided by x is 9 minus the invisible 1, which is x to the 8th. And then on the y's, 4 minus 2 is 2. And I personally would get rid of that 1 in the numerator in my final answer. I won't mark it off if you don't get rid of it, but it's just more simplified to not have the 1 there. Pause the video, try 10. On 11, we want to do some evaluation of functions. So if I want to do f of -1 minus g of 2, I'm going to evaluate the f function when x is -1. So let me start with that. So f of -1 equals, and then wherever I see an x, I'm going to plug in a -1 in parentheses. And then I need to follow order of operations when I'm simplifying this problem. So exponents come first. So 3 times -1 does not happen first. You need to do -1 squared is 1, like that. And then you can multiply next. So 3 times 1 is 3. And then 3 minus 2 is 1. Then, off to the side here, I'm going to do g of 2. So g of 2 equals, wherever I see an x, I'm going to put a 2 in, like that. And then remember, with following order of operations, I need to work inside the absolute value bars first. So 2 minus 4 is -2. And then the absolute value of -2 is +2. And the absolute value bars turn into parentheses. And then 2 times 2 is 4. 4 plus 1 is 5. Now at the very end, don't forget to answer the question. It was f of -1 minus g of 2. So basically I have 1 minus 5, which is -4 for our final answer. Pause the video and try 12. On 13, we want to do the inverse. That's what this notation over here is, f inverse of x. So whenever we're finding inverses, remember, f of x or g of x or h of x or m of x, whatever the function's name is, that's the same as y. So f of x is y. So that's kind of like step 0. And then after that, you're going to switch x and y. And then once you've switched x and y, we now are going to solve for y by doing order of operations backwards. So I'm going to get rid of that division by 4 by multiplying both sides of the equation by 4 to start. That way these 4's on the right side cancel. So I have 2y minus 7. Again, I'm trying to get y all by itself. So I'm going to add 7 to both sides. Notice the 4x and 7 are not like terms. So I'm just going to leave it like that, 4x plus 7. I just leave it separate. Then to undo multiplication, I'm going to divide by 2 on both sides. At the very end here, just because they used the function notation and they asked us to find f inverse of x, I'm going to write my final answer as f inverse x equals, and then my answer. Go ahead and pause the video and try number 14. And then last but not least, 15 looks like a trig word problem. So I'm going to draw myself a right triangle, and Stella is sitting on the ground looking up at a squirrel in a tree. The squirrel is 30 feet up in the tree, so 30 feet up in the tree. And then Stella is 24 feet from the base of the tree. And then I want the angle of elevation. So angle of elevation is from the horizontal going up. And then we're going to round to the 2 decimal places. So when I look at my labeled picture over here, with respect to that orange X, I have the opposite side and I have the adjacent side. From trig, we have SOHCAHTOA. So TOA is opposite over adjacent, meaning we're going to use tangent to solve this problem. So tangent x equals opposite over adjacent. Now the only way to unglue the trig function from the variable is to do the inverse trig function. So I'm going to do inverse tangent on both sides of the equation, because that's how I can cancel out the tangent that is currently attached to the x. When you're using your calculator, make sure you are in degree mode as opposed to radian mode, because you're going to get the wrong answer if you are in degree mode on this one. So then, let me type that in. With a calculator, you usually have to hit the second key. So second tangent 30 divided by 24 gives me 51.34. And then let's see, units. We just found an angle, so I'm going to do degrees because we just found an angle. Remember, if you're using trig to find a missing side, that's when you would cross multiply. We were finding a missing angle, so that's why I did inverse tangent. Pause the video, try number 16, and you are good to go.